I'm excited to talk about this topic. It's kind of near and dear to my heart. The big picture here is I've talked to a lot of data scientists, and as people probably know, a lot of data scientists come from different backgrounds and have had different paths. And so this is really just kind of the tail of my path to data science, and hopefully you'll be able to glean some things that may be helpful in your own. So when I was back in college, around 2006, there was an article in Bloomberg Business Week about the great future of mathematicians in the career industry world. This quote from the chief of the mathematics research group at the NSA said, "There has never been a better time to be a mathematician." So that sounded really inspiring to me as I was a math major. I thought, okay, this is great. I'm on the right thing. I've chosen the right career path. But when I was sitting in my classes doing work, this is what I was seeing, right? So here's a picture from one of my textbooks, which is abstract algebra-based number theory. And I was really having a hard time finding anyone beating down my door to hire me to do proofs about number theory using abstract algebra. So there was a real disconnect for me between what I was hearing from this news article and other media, like, oh, it's a great time to know math, it's a great time to be a mathematician. And then on the other side was, okay, here's what I'm actually doing day to day. How is this going to get me a job? So these are the math classes I took in college, just to give you a little bit of context. Probably a lot of these look familiar to many of you if you're studying math or related fields. And the point here is that this is a really good foundation in math. Like, if this is the best time to be a mathematician, I thought, well, hey, I should be in a great place. But as you look at these, you realize, if you know something about them, all the ones on the left are basically proof-based, right? So I'm working out proofs on paper and maybe doing a little bit of computation on paper here and there. The ones on the right, numerical analysis, I was doing a little bit of programming, mostly in Mathematica, but not a lot of programming at all there, or even building bigger software tools to do that. So I was trying to figure out, like, how do I get from these things that I'm doing in my classes to getting to this great promised world of the best time to be a mathematician. So when I was looking at job postings, I was hoping somebody would say, oh, you should have a bachelor's degree in computer science or similar, experience with C++, which I had learned a little bit about in school. And you definitely are going to need a very deep understanding of the Cauchy integral theorem from complex analysis. But the reality is that no one was hiring for the Cauchy integral theorem, and I couldn't find anybody who really cared all that much about what I perceived to be math or what I was doing in my math classes. And so I had this big realization that nobody is hiring based on ability to prove properties of Hausdorff spaces, right? So that's not Hausdorff spaces in particular being interesting, but that very few jobs are actually directly related to what you're doing in a math class. So if you're studying math, what you're doing most of the time is pulling out sheets of paper and proving proofs based on theorems and definitions that you learned in your class. And maybe you have a few classes where you're doing some computation here and there, but for the most part, you're just doing all this proof-based work. And very few people in their careers, and the reality is very, very few data scientists are spending a lot of time working out mathematical proofs. So I was realizing that there was just a difference between what these news articles and media perceived as math and the value of math, and what I was actually doing in my own coursework. So the challenge for me then has been drawing connections and getting value out of what I studied then to getting me towards what I can do now. So as an example of what I do now, over the last week, I've thought about some things like, how can I get scikit-learn to run on AWS Lambda, right? So a machine learning library on a cloud computing tool. How can I communicate with other engineering teams and get them to spend time supporting my data science projects, which are kind of interpersonal and relationship and internal sales kind of challenges in a company. How can I fix my Python environment so I can get it to work with the fish shell that I have for some reason chosen to use on my work computer? Why are suddenly my Python scripts not running? How can I think about designing experiments to collect data from web users when they exhibit adversarial behavior, which really flies in the face of traditional experimental design? So the point here being that none of these things have anything at all to do with what I was learning in college in my math classes. And so, again, there's this big disconnect. The greatest time to be a mathematician, and then me as something of a mathematician doing work that seems completely unrelated. John Cook, who's a friend and mentor of mine, and if you don't read his blog, if you want to become a data scientist, you should start reading John's very prolific blog. But John likes to use this term very applied math to denote a subset of applied mathematics that's actually applied to real problems. So if you know the way academics use the term applied math, it's usually more about solving differential equations than it is to actually applying math to real world problems. So John wants to figure out how to do very applied math, so math that's actually applied. And this is what I'm interested in, and this is what I've tried to become as time has gone on. So as I look back at my curriculum that I had in school, here are some of the holes that were lacking in allowing me to get into a data science field. One is very applied statistics. So you could potentially take statistics in school, but statistics are not immediately and obviously going to be valuable for applying to real world problems unless you learn how to do that well. Machine learning was something I knew nothing about. I don't think I'd even heard that term until after I was out of college. The Python language I picked up in grad school reading a book called Learn Python about Python. It's been an essential tool for me as a data scientist. Practical computing skills, things like command line tools, version control, things that are essential to me every day, were completely lacking from my curriculum. Software engineering skills, how do you build software that's maintainable and testable, that is reliable, that's readable by others, all these different things really missing. Software operations skills, I think this is one of the biggest challenges many data scientists face. How do you get these things that you've written in code to run in a way that's going to be, it's not going to go down, and it's going to have monitors around it, and that's going to be scalable to as the data grows, or various things. So all these things are aspects of data science that students aren't learning in math classes or in math degrees. And so I'll walk through a little bit of how I got to where I am, despite having all these holes. And if there's one takeaway I can offer, if you're studying math or a similar discipline, and arguably maybe anything in college, you're not going to learn all of this. And that, in some ways, maybe that's for the best. I don't know that colleges necessarily should be focused on all of these things, but you can start to think about how you can fill in the holes in your own life, and even more importantly, how you can just constantly be learning throughout your career, which is an essential aspect, I think, of a data science career. So a few items of how I became a data scientist, despite not having all of these things in my education. One is, as much as I would say that mathematics degree doesn't really prepare you for a career in data science, math is certainly essential in understanding the theoretical underpinnings of data science when we start to think about machine learning models, when we start to think about statistics, and even in some ways computing itself has mathematical underpinnings. And so having had that has been really valuable for me in that I can understand research papers, I can understand theory, I can deal with abstract concepts fairly easily, and it has been really valuable for me. It's been necessary for me in some ways, but it hasn't been a sufficient aspect. Unwittingly, I took a number of courses that later played an important role in my data science toolkit. Sort of just out of my own interest, through my undergraduate and graduate career, took 5 semesters of linear algebra classes. Linear algebra it's hard to know when you're taking it early on in school, but it ends up being an essential aspect of so much computation that we do. And understanding that linear algebra from a theoretical level has helped me to be able to pick up machine learning models and algorithms, and help me understand how to debug things when they have issues. I took various mathematical statistical courses and stochastic processes courses, which again provided a very theoretical foundation for things that later on I started to understand the applications of. So for me, often the theory long preceded me knowing how it's applied, but many times those things actually can be applied. Don't discredit the value of those theoretical classes. They can prove to be very useful. I did a minor as a computer science as an undergraduate. I would actually commend this highly if you're able to do something like this. This provided a foundation for me and some knowledge of programming languages. I learned SQL for the first time really in a databases class. I took an algorithms class as part of my minor, which has been invaluable to me in thinking about computing from an efficiency standpoint and using the right kind of data structures and algorithms to solve problems. It's been a really valuable asset to me on top of my math degree. And I would think it is a fair thing to say that a math degree on its own, without any computing skills, is essentially useless to most employers, except potentially teachers and professors, maybe, if that's a route you want to go. But if you are a mathematician that can't program, probably no one is going to want to hire you, because almost all math used in a business and industrial setting requires computing skills. Another thing that has proven valuable to me was getting a master's degree in operations research, which is a field that is focused on applying mathematical models of optimization and similar models to real-world business problems. And I did that master's after realizing I wasn't going to be a career mathematician in a more traditional sense. And I don't know that I would necessarily recommend this as a good route, but for me, it's proven really valuable, and it helped me to start to think about how mathematical models can apply to real-world problems. It allowed me the freedom in my particular program here at North Carolina State University to take classes in the computer science and statistics department. So I was able to take machine learning and statistics classes that have proven valuable to me. It taught me about optimization, which is really the foundation of so much machine learning and statistics. And these models, you're like trying to find the best model. Those are just optimization problems. So that's been a valuable tool for me. And I think it potentially could be a valuable tool for others. Although, again, on its own, I don't know that it really prepared me for a career, but in combination with other things has been really useful. I also have been fortunate to have employers who have patiently taught me and given me freedom to learn on my own. I've had great coworkers here at Distill Networks as well as at other companies. And I have been in the industry now for 5 years and have just learned an enormous amount through colleagues and through companies training and having the flexibility to learn things on my own. And that's, I would say, one great life skill is never just assume that because you're in a job that you can't be learning more or it can't possibly change. But maybe you can start to spend a few hours each week picking up Python to apply it to a work problem, or I don't know, similar things. You can learn on the job, and it's such a great thing to find an employer who really encourages that, and that you have really great coworkers. And I would recommend, if you're early on in your career, one of the best things you can probably do is try to find a company where you're working with really smart people who will be willing to teach you and help you, because they're no matter what you learn in school, there's so much more to learn in industry. I think this is really one of the most important points. I said my insatiable curiosity in computers and problem solving has played a key role in my success. And what this looks like has been, ever since I was a kid, a curiosity about computers and using computers to solve problems. In college, in my math classes, I often tried to write little scripts in Mathematica or C++ to solve problems I was working on in my classes, not because I had to, but just because I thought it was interesting to try to get the computer to do that. And in hindsight, that was really great preparation for my current work. Just wanting to know more, wanting to learn how to automate things, wanting to learn how to solve problems is really one of the best skills that I have in my career, in combination with my education, has really helped me get to where I am today. I will just add to that one final point that I would say one of the most important skills that all data scientists have today, kind of on top of the curiosity and desire for problem solving, is just a tenacity and willingness to not give up when problems are hard. So many of us are using new technologies, using new tools, using computers that are frustrating and unreliable, using math models that can be confusing. Just being willing to keep going until you get your problem solved is such an essential part of this work. I will stop now for questions.
Tim, thank you so much. This is really right now the Q&A is blowing up because this is quite a relevant question to many people who are in the conference right now. I'd like to talk a little bit more about the value of math degrees or math education, especially from the employer standpoint. From your experience, do you find that people respect data scientists that do have degrees in math? Do you find that other degrees are potentially more relevant? What kind of moral support can we give for people with the mathematics degrees out there?
I think there's actually a weird imbalance here that partially inspired me to start thinking about this, which is people have in theory, employers really value math degrees because they think it is the kind of thing they need. I think in practice, the bigger picture of this is a math degree on its own is not sufficient for a successful career in data science, and that you need these programming skills. You need to be able to think about math modeling in a real world situation. This very applied mathematics, that kind of thing. And I think if you can come to an employer with a math degree and also show that you have these basically applied practical skills, that's really valuable. But if you don't have the math, if you only have the math degree and you basically know what you learned in your math classes, I think people are not going to find that very useful. Even though, again, going back to the first point, like that, I think it may help you get in the door. It may help you get interviews because people think they want math majors, but I think a lot of people just don't really know what a math degree actually is. In terms of other degrees that may be valuable, I think that's a hard one to answer. In hindsight, if I was doing it all over again, I might try to double major in computer science and statistics. I think that's probably the most similar thing to data science, or similarly, some combination of those math, statistics, computer science with a major and some minors or something like that. I did not have much opportunity for applied statistics class in my undergraduate, and I would say that was a hole in my education going forward.
Great, great. We're also getting a few questions, namely from Matt A's and using DS handle. The merit of having an advanced degrees, either a master's degree or PhD degree, these are very common degrees to have in the field of data science. What are your thoughts on whether they are prerequisites or at least helpful when it comes to both learning data science and getting into the field?
Yeah, so I have a master's degree, and a lot of job postings I see say they want someone with a master's degree or a graduate degree. I know of several very successful data scientists who don't have any college degree even, but I would say it's probably an exception. I found getting a master's degree very useful in the things that I learned beyond my undergraduate degree. It was very valuable for me, and I think the value of a master's degree, if you can do it in a reasonably affordable way, the time commitment of 1.5 to 2 years makes it really worthwhile. Some people may know I have a website, actually, shouldigetapphd.com, where I interview several people in computing professions more broadly about the value of a PhD. I'm generally a skeptic in the real career value of a PhD in terms of helping you in your career and providing you with skills that are essential. I think if you spent the same amount of time in a good job working with good, smart people, you could get as much value. So my recommendation to people often is try to get a master's degree at the best place that you can get into and can afford or can do with reasonable loans, and then get into industry as soon as possible. Unless you just really, really want to do a PhD and that just sounds great to you. But I'm not convinced that it really pays off from a career perspective.
Okay, thank you so much for that. Tim, you've been fortunate, I'm going to dare say, to have had an employer actually help you acclimate into what is necessary to become a good data scientist. Julia Marder is asking what kind of tips you might have for other people looking to be trained and invested internally by their companies to be data scientists as well. Is it something that companies will advertise, or how do you potentially go down that path?
Yeah. I think that's an important thing to think about. I was fortunate to get a job as a data scientist right out of grad school. In hindsight, I was hired by a company that wasn't totally sure why they needed a data scientist or what that meant for them. And that ended up being good in some ways, in that I ended up having a lot of flexibility to try to shape that in ways that were valuable for me, and it was bad in other ways in that I didn't end up having long-term a lot of work that was really relevant to what I wanted to be doing. I suspect it's harder now than it was in 2012 to get a data science job with the qualifications I had at that time. I don't know if that is true for sure or not, but I do think it is really valuable in whatever field you're currently in. You don't need the title data scientist to be doing data science type work. And I would commend to people to, like I mentioned earlier, maybe you're a programmer, maybe you're a business analyst, and you see these kind of data science problems that seem interesting to you. Start to think like a data scientist and start to solve problems like a data scientist. And I suspect your company is going to find that really valuable. So, for example, if you're a business analyst, maybe you generate business intelligence reports like Kirk was talking about before. Maybe you can start to pick up tools and skill sets where you can automate some of that. You can use Python or something to automatically, or R to automatically generate those reports.
Hey, Tim, we're going to have to unfortunately cut you off. We're just out of time, but
Great.
Thank you so much for jumping in and answering all these great questions.
Thank you.